Thank you for the request to go through question 11 and the review exercise 2, where we had a circle with a centre 0, 0, so knowing that we know the equation of the circle is x squared plus y squared equals r squared, and a straight line with the equation y equals 3x minus 2, and we're told that this line doesn't intersect with the circle, and we're asked from that what could r be, what are all the possible range of values of r. Well, perhaps like what's confusing about this is actually we should start by considering if it did equal, if it did intersect, and if it did intersect at just one point, and then from that we can consider when would that not be true, when would there be no solutions for that to be the case. So it's perhaps a bit confusing that that's where you're going to start off, and that makes it perhaps a bit more difficult as a question. But if it did intersect, if it say just touched here with one solution, we'd be able to substitute our y value into our equation of a circle. So instead of x squared plus y squared equals r squared, we could use the expression for y in the straight line graph. So instead of writing y squared, we could write 3x minus 2 all squared here, and that's equal to our r squared. If we work through that, we get to the point where 10x squared minus 12x plus 4 minus r squared is equal to 0. And we've got a quadratic that we can take the discriminant of. So if we remember our discriminant b squared minus 4ac, that would be equal to 0 if there was just one solution of this problem. It would be greater than 0 if there were more than one, or if there were two solutions, in this case, for that problem. We're considering when there's going to be no solution, so we need to consider when is that discriminant going to be less than 0. And if we work our way through substituting our values in for this, well, our b squared is going to be negative 12 squared. And then we're subtracting 4 times by r 10 for our coefficient of x squared times by r 4 minus r squared as our constant. And we know that that's less than 0. Working through that, we get to 40r squared minus 16 is less than 0. And then we can solve that to find that 8 lots of 5r squared minus 16 is less than 0. If we're solving a quadratic inequality, what we should start by doing is considering if this is equal to 0 and then sketching it. So the 3 steps I'd say are solve, sketch and consider. So if I solve my 8 lots of 5r squared minus 16 equals 0, then I would get that r is plus or minus the square root of 2/5. And if I sketched that, my second step, a sketch of this problem of 40 over 8 lots of 5r squared minus 16 equals 0, that quadratic would give me this, with these two roots at negative 2 root 5, negative square root of 2/5 and positive square root of 2/5. Now if I think back to the original problem, I'm considering when is this less than 0. So this is less than 0 between these two values. So the possible range of values for r, to summarise the answer to the question, is that it's between the square root of 2/5 and the negative square root of 2/5. Problem is this is a circle, So given that you can't have a negative radius of a circle, and this is why things like sketches are really important, to just double check your answers before you move on and finish. Given that we can't have a negative radius, it must be the case that r is greater than 0 but less than the square root of 2/5. And we'd be perhaps intuitively expecting an answer similar to that, where we'd not expect a large radius. The larger this radius gets, then the more likely it is to intersect with this line, so we're expecting quite a small radius. And again, we're not expecting a negative answer for the radius either. So I hope that explanation helps. I would highly recommend having a go at question 10, which is very similar really, in the same review exercise if you struggled on this problem, and to get in touch if you struggled with that question, and I don't mind doing exactly the same thing again and talking you through the solution to question 10 as well as question 11. Hope that helped.